Students, welcome to Ascent School of Science e-learning platform. I am educator Santosh Kumar. Today we are going to discuss 11th mathematics logarithm lecture number 3. So let us start. So already we have discussed some problems and properties of logarithms in last two lectures. So today we are doing some problems based on these formulas. They are asking to prove log a plus b upon 3 is equal to 1 upon 2 into log a plus log b. The condition, given condition is a square plus b square is equal to 7ab here. Okay. Now, see here, a plus b upon 3 is equal to 1 upon 2 into a plus log b. So they are asking to prove like this. So given condition is this. So I am taking the condition and adding 2ab on both the sides. If I add 2ab over here and if I add 2ab over here, this becomes 9ab. So this becomes a perfect square, so that I will get a plus b whole square term. So see here, we required a plus b. So a plus b whole square we are going to get from this. So see here, a plus b whole square is equal to 9ab. I am bringing this 9 this side is equal to ab. So I am taking square root on both the sides. If I take square root on both the sides, what we are going to get? Here it will be a plus b. Square root of 9 will be 3 is equal to square root of ab, that is ab raised to 1 upon 2. Now apply logarithm on both the sides. So taking log on both the sides, what you are going to get? So logarithm of a plus b upon 3, left side part we got, is equal to logarithm of ab whole raised to 1 upon 2. So already we have studied a formula. We have learned a formula, log a raised to m is equal to m into log a. So this power 1 by 2 will come into the front as a product. So what we are going to get? See here, log a plus b upon 3 left side as it is, and this power will come into front. So like this, 1 upon 2 into log ab. Again log ab formula will be log a plus log b. So hence proved. Now let us go for second question. So they are asking to find the value of x, solve for the x, and condition, given condition is log 2 to the base 4 and log x to the base 3 is equal to 1 by 2. So three logarithms, one log is inside of another log is inside of second logarithm, like this. So log x either to the base 3, either to the base 2, either to the base 4 here is equal to 1 by 2 given. So how I am going to solve? So we have studied how to convert exponential form into logarithm form into exponential. So we are going to use that formula here. So this condition is given. I am converting this first logarithm, means I am eliminating this first logarithm or converting this first logarithm into exponential form. So if I delete this logarithm, what will happen? So this 1 by 2 will come to the form of 4 raised to 1 by 2, and this entire term will go right side. See here, log 2, this entire term will stay here only, and 1 by 2 will be in the form of 4 raised to 1 by 2, that is 4 raised to 1 by 2. Logarithmic form is converted into exponential form. So what is mean by 4 raised to 1 by 2? That is 2. Again, now remove this second logarithm, means first logarithm, this logarithm of base 2. So if I remove this logarithm, what happens? This 2 come to the power of 2, and this log x to the base 3 will go other side. So what you are going to get? Log x to the base 3. Log x to the base 3 is equal to 2 square, means that is 4. So x value you are going to get 3 raised to 4. So 3 raised to 4 means x value will be 81. Now see another example. So here they have given a equation like this: a raised to 3 minus x into b raised to 5x is equal to a raised to 5 plus x into b raised to 3x. Then they are asking to show x into log b upon a. Log b by a means log b minus log a indirectly is equal to log a. So how we are going to prove this? So first I am going to arrange these terms, all a terms left side, all b terms right side. Okay. Now see. So bring this bx, b raised to 3x left side, and a raised to 3 minus x right side. So after that simplify. So a raised to m upon a raised to n will be a raised to m minus n, that is b raised to 5x minus 3x. 5x minus 3x will become 2x. Here a raised to 5 plus x upon a raised to 3 minus x, it becomes a raised to 5 plus x minus 3 plus x, it becomes a raised to 2 plus 2x. Now take logarithm on both the sides. So what you are going to get? Log b raised to 2x is equal to log a raised to 2 plus 2x. Now this exponent will come in front as a product. This also will come over here. So what we are going to get? 2x into log b is equal to 2 plus 2x into log a. Now split this bracket. So what we are going to get? So 2x into log b. Here first I am cancelling here 2 and here also 2. So after multiplication log a into the bracket, so what we are going to get? X log b is equal to log a. Actually 2 got cancelled, here 1 will be left. 1 into log a become log a plus here only x into log a. So now bring this x log a this side. So what we are going to get? X into log b minus log a is equal to, so log a. So after bringing this x log a to the left side, take x common, that becomes log b minus log a is equal to log a. Log b minus log a can be written as log b upon a. So x into log b upon a is equal to log a. So hence proved. Now let us move for next question. Here before going to some questions here, so what we are going to find out the formulas. So see here, sum of first n natural numbers. Sum of first n natural numbers. What is mean by natural numbers? So 1, 2, 3, 4 up to so on. So up to n natural numbers we are going to take, and sum of this n natural numbers. So see here, some function can be represented as summation n. So summation n is equal to 1 plus 2 plus 3 plus up to so on till n. This value is equal to n into n plus 1 upon 2. Just use arithmetic progression formula to find sum of n terms. Okay. Next, similar way, sum of the squares of first n natural numbers. So summation n square, that is 1 square plus 2 square plus 3 square up to so on n square. This value is equal to n into n plus 1 into 2n plus 1 upon 6. Here also we will use sequence and series method, like method of subtraction. And summation n cube, that is 1 cube plus 2 cube plus 3 cube plus up to so on n cube. So this value is indirectly square root of first formula, that is n square into n plus 1 whole square upon 4. So these all proofs you will get in sequence and series chapter. Next, sum of first n odd numbers, that is 1 plus 3 plus 5 up to so on 2n minus 1. Here also you can apply arithmetic progression formula. So in 10th class you have studied. So sum of first n natural numbers is n square. Now we are going to apply some questions, means apply the formulas in some questions. So see here, summation I is equal to 1 to n log a to the base I, means log a to the base 3 raised to I they have given, 3 raised to I. So they are asking to prove this side, left side, right side. See here. So what I am going to do is, here the formula log a to the base b can be written as 1 upon log b to the base a. So if you bring into numerator into denominator logarithm term, so what will happen? Base and the logarithm value will interchange. So see here, this question was given. So I am taking here 3 raised to I can be written as 1 upon I into log a to the raise 3. So if base has power, in last class we have studied base has exponent, thus exponent will come into the front side in the division. So that is this I will come over here 1 upon I, like that you will get 1 upon I into log a to the base 3. So 1 upon I, if I take into numerator, I upon log a to the base 3. So now this is a constant, there is no dependency of I in this term. So you can bring outside, or you can take it into numerator. The same term I have written. See, I brought this term into numerator. So if I bring this term into numerator, what happens? And 3 and a will get interchange. Now, so this is entirely constant I am bringing outside. So what happens? summation I, that is 1 plus 2 plus 3 plus up to so on n actual number, that value will become n into n plus 1 upon 2 into log 3 to the base a as it is. Next question. So see here, there is an expansion was given. So 1 upon log a to the base 2, 1 upon log a to the base 4, 1 upon log a to the base 8 up to so on till n terms. This value they have given as n into n plus 1 upon k, then they are asking to find the value of k. So let us see. Here some options are also given. Okay, which option is going to correct? So what I am going to do is, here this logarithm term, take it into numerator. So if you bring this term into numerator, what happens? This 2 and a will get interchanged. So here log 2 to the base a, same log 4 to the base a, log 8 to the base a, and log 16 to the base a up to so on n terms. So log m plus n formula is log m into log n. What we are going to get? So see here, log 2, this 4 can be written as log 2 square, log 2 cube up to so on log 2 raised to n, because first term is having 2 raised to 1, second term 2 raised to 2, third term 2 raised to 3 up to so on nth term will be 2 raised to n. See here, entire logarithms, all logarithms with the same base. So log m plus log n formula you can apply. Log m plus log n will be log mn. So you will get log 2 into 2 square into 2 cube up to so on 2 raised to n to the base a. Now bases are equal, powers can be added in the product. So what happens? Log a log 2 raised to 1 plus 2 plus 3 up to so on n to the base a. Now so see here, 1 to n, sum of first n natural numbers will be n into n plus 1 upon 2. So this power will come into the front as a product. So n into n plus 1 upon 2 into log 2 to the base a. Now here in the question they are asking n into n plus 1 upon k. So there is no term in the product, only all terms, remaining all the terms in the division part. So I am going to bring this log term into the denominator. If I bring it into denominator, this a and 2 will get interchanged. See here, it becomes 2 into log a to the base 2. Now this 2 will come into the power of a square. So log a square to the base 2. So from this k value is log a square to the base 2. The answer C is correct. Now one more question. See here, this symbol is called factorial. What is mean by factorial? So 200 factorial. For example, if I say 5 factorial means from 5 in reverse up to n you should multiply all the numbers. Like 5 factorial means 5 into 4 into 3 into 2 into 1. If I take 6 factorial, 6 into 5 into 4 into 3 into 2 into 1. If I take 10 factorial, instead of writing in reverse, I am writing like 1 into 2 into 3 into up to so on till 10, the product till 10. Like here 2020 factorial means 1 into 2 into 3 into up to so on till 2020, the product is called factorial of 2020. Now see here, they have given so many logarithms in addition, like series same previous question. So take this into numerator, all terms take it into numerator and simplify, you will get the answer. So see here, going to apply these two formulas. Already we know these two formulas. Now this question was given, take it into numerator, all terms take it into numerator. So you will get log 2 to the base n, log 3 to the base n, log 4 to the base n up to so on log 2020 to the base n. Log m plus n formula if I apply, it becomes log m into n. So in this by using this formula, I entirely combine this all logarithm into one logarithm. It becomes log 2 into 3 into 4 up to so on 2020 to the base n. Here nothing is there means 1 is also there. So if I multiply with 1, there is no problem. So indirectly 1 into 2 into 3 into 4 into up to so on 2020. This entire term become 2020 factorial. 2020 factorial. Now they have given 2020 factorial as n. So I am replacing with this value with n. So log n to the base n. If base and this logarithmic value is same, then this value becomes 1. Okay. So thank you students. If you like this video, please share कीजिए, subscribe कीजिए our channel को. Thank you very much students.